Okay, so let's start by writing the right-hand side in terms of sine and cosine. We already do have the cosine theta, and then let's go ahead and write tangent as sine theta over cosine theta. And this is something to get used to seeing, is we can cancel these out because this is really just cosine over 1, and we just end up with sine theta, which matches our left hand side. In this problem, generally my advice is to change everything into sine and cosine, but if you get used to recognizing Pythagorean identities, then we can go ahead and turn this into secant squared first. So cosine squared times secant squared theta equals 1. Now, if you're not familiar with this, now let's go ahead and turn it into cosine. So cosine squared theta times 1 over cosine squared theta. And then we get that relationship that we've seen before where we can cancel this out and we get 1, which matches our right-hand side. Now, this fact, I will say, is a fact that you can memorize as cosine times secant is 1. You don't have to turn it into cosine to be able to cancel them out. But this right here is the proof as to why that's true. So once again, I'm going to go ahead and turn this into sine and cosine. I won't do that for this yet, okay? And the general rule with these fractions, -1, pardon me, is that when you have matching denominators or numerators within a complex fraction, you can just go ahead and cancel them out because it'll amount to multiplying by 1 over sine squared, 1 over sine squared, and they'll cancel out. So we have 1 over cosine squared theta over 1, and really over 1 is itself, and so this equals 1 over cosine squared theta minus 1. Now, I've said in the past that there are times where you'll want to turn stuff from sine and cosine into other things. And I think this is one of those moments. We have a Pythagorean identity that we can then match to tangent squared theta. This one looks a little tricky because everything's already in terms of sines and cosines, and what we have on the left-hand side looks close to a Pythagorean identity, and same for the right-hand side. It's that pesky little 2 that's getting in our way. So how are we going to tackle this? What I'm going to do is I'm going to go ahead and I'm going to start with the right-hand side. And I'm going to take this sine squared theta and I'm going to substitute in our Pythagorean identity. That'd be 1 minus cosine squared theta. So it's going to be 2 cosine squared theta plus 1 cosine squared theta. And then if we can look past it for a second, we have 2 of something minus 1 of that same something. So this would just end up giving me cosine squared theta plus 1. Now, it's not quite the same as what we have on the left side, but remember addition is commutative, so we are done. In this problem, this one's kind of tricky because do we deal with the left hand, do we deal with the right hand, do we deal with both? I looked at this and I think the best approach is to deal with the right-hand side. So let's go ahead, I'm going to distribute this tangent. Okay, so we get this to cancel out right here. Now, I'm not going to compute this because, and I'll show you why. So here's a little trick you can do. If you notice that they have something in common, we can take out that something in common. We're factoring it, so I get, and if you see, we have the same thing as our left-hand side. You could have also distributed this sine theta, and notice what we would have gotten something similar to what we have here, and that would have been okay. And remember, addition is commutative, so this is the same as this. Okay, so for this one, let's go ahead and turn this into sine and cosine, so that'd just be sine theta times, times sine theta over cosine theta. And then I'm going to write this as cosine theta over 1, because now we can start to see it as adding 2 fractions together. And if I go ahead and grab a common denominator, which would be cosine theta, I get sine times sine is sine squared. I get cosine times cosine is cosine squared all over cosine in the denominator. And now here we have our magical Pythagorean identity. You'll always want to recognize this, so you can substitute in 1. We still have cosine in the denominator, which matches our right-hand side. So I'm going to go ahead and tackle the right-hand side. Okay. I'm going to write that tangent in terms of sine and cosine. So we'd have sine theta times cosine theta times sine theta over cosine theta. And we've seen this before where we can cancel this out. Now this times this will just be sine squared theta. And this is where we can go ahead to our Pythagorean identities and grab the fact that this is equal to 1 minus cosine squared theta. And that gives us our left-hand side.